Hey guys, my name is Mudasir. I've been working at Dubizzle for almost 5 to 6 years now. I left Dubizzle and came back, so that's a separate story. We can do that later on. So yeah, today we'll see how we can perform, secret handling in different cloud native applications. First thing, a bit about Dubizzle. I think most of us know that Dubizzle has been here for almost 10, 12 years now. At average, we have around 8 to 10,000 requests per second, but in peak times, I've seen going up to 20,000 as well, but that's over the weekend sometimes. In 12 years, we started with a monolith application, but we now have monolith plus just over 40 microservices as well in production. Logs is our main source of truth. We're generating almost 500 million logs every 15 minutes. We do a lot of analysis, graphing and all that stuff on that as well. We use Beanstalk, Elastic Beanstalk, a service by AWS heavily. Everything is Docker. Every service that we push out is a Docker container, and it's deployed on Beanstalk. And everything is in a CI/CD pipeline. It deploys to Beanstalk. Automatic deployment happens. Sometimes we have blue-green deployments, sometimes we do canary deployments, and we have an in-house tool that we built to automate that. An advanced thing is that in-house tool that we have built has the integration with Vault that we'll see what that tool is and how that works as well. Thing is, conventional methods of handling secrets. This is something I think most of us have already seen, and most of us have already practiced as well. Started with untracked settings file, some configuration file that we don't track anywhere. This just laying around on some server that's secret. But and then environment variables, as if your application has to be a 12-factor app, that it has to have everything with environment variables as well. And then configuration management tools. These are the conventional methods that almost all of us have had used in a way or the other. Not the so the issues with that these things is the thing is these are not actually designed to handle these sort of things. Like, how can you make sure that you have 10 APIs with different API keys and just put them in a single settings file or in any environment variable on the system, which is actually available to every process running on that system. So if a malicious code actually gets in your system, that even that code has access to the environment variable. So these are the things. Almost none of these have, almost I would say not all, but yeah, limited access control or no access control at all. Audit is one of the most difficult things. Who used it, when it was used, why it was used, when did we change it, when the previous API key was revoked, or who rotated it, these sort of things. The biggest issue, revocation. If something happens, how will you revoke something that is in a settings file that has not been tracked at all, or in an environment variable that is available to every process in the system? Or in a configuration management system, which is literally a plain text storage, simple as that. Even if you encrypt it, the data available on your system is plain text and it's available to every process. So these are the issues that actually we have had before. From our experience as well, we have been, it's like hit and trial case. We try something, we change it, we try something, we change it. So these are all some things that we have tried over the period of 12 years now almost. And yeah, these are the biggest things. When something happens, when you get notified by something or some alerting system, or some of your customer support guys, or some of your customers, or somebody says, I think we have been hacked. So these are the things like, okay, who has the access to secrets? We need to change it. When were the secrets used? Who used it? Which secrets actually, so out of let's say 10 APIs, you don't need to change all 10, you just need to first figure out which API, and then you only change one of them or two of them, and then deploy it again, and do the whole process for every service which is available which is using that certain API, and implementing a thing that is in like this sort of thing being implemented in a CI/CD case, it is a nightmare, to be honest. Like if you change one API key and you deploy it, which service got the correct API key, which does not, does all get deployed, is there any previous environment running with the old API key or not? So these are all the questions that we have faced and we have had, and when things do go south, the aftermath is like literally you have to revoke access. But revoke access of what? First is that, how do you revoke it? Let's say if you're using S3, or let's say if you're using GitHub API or any other API, you revoke it, you have to log in to the console, generate a new API, make sure that the old one is disabled, or literally create a new user or IAM role, and then revoke it. Like, just imagine doing that for 10 API keys with different consoles or different providers. So this is the big issue. Revoking is one part and rotating is another part. Revoking is done. Now you need to generate it and then provide that new API key to the applications again. So that first part is easy, I think, for some guys. You can just log in, change, and that's done. Rotating is you need to generate new keys, put them in whatever configuration management, settings file, environment variable, or whatever method is being used, and then deploy it again. And then run audit trail, actually when or which service used the API key to do what. So these things are really big issues, especially in the Dockerized environment, in the containerized environment, is you don't actually, like literally if you have 40 services like we have, you cannot go in and in any one of the Docker containers, each service running 15, 20, 30 servers, and just see what actually got compromised. So this is one of the biggest things we have actually witnessed. And so now the secret management 2.0. This is, we started looking at something called Vault. It's by the HashiCorp guys. The thing is, for any 12-factor app, everything has to be an environment variable. Every configuration part has to be environment variable. So this makes a bit difficult as well, because environment variables usually are available to every process in the system. To overcome this, HashiCorp guys have actually written a really good tool, Vault. It provides a secret storage store. Obviously, we don't use in memory just for development. You can use console as backend for storing your secrets or authentication or authorization. You can use MySQL. There are like at least 10, 15 backends available. You can use, I think, Zookeeper, etcd. A lot of them are there. Dynamic secrets, so you can generate API keys, database passwords, and a lot of this stuff on the fly. So you don't need to log into the console or log into the application or to the MySQL literally CLI to generate anything. Vault does it for you automatically. Leasing, renewing, and revocation. That's one of the best features is you can set a lease time for every key that you generate using Vault, or every key that you fetch using Vault as well. So obviously there are some things we don't generate frequently, or there are some API keys or some things we store in Vault or some we store somewhere but we don't want to change it. So we set a lease time on that. Lease time means, let's say if any application fetches that data, we can set a lease time of 5 minutes. Say for example cron jobs. Cron jobs run 5 minutes, 10 minutes, 1 hour max for some examples I would say. So we can set a lease time for saying generate a dynamic secret and just set the lease time for 1 hour. So after 1 hour, that dynamically generated secret will automatically be nullified. So you don't need to worry about what happened to that secret, oh where is it, what happened. Auditing part is built into the core of Vault. It provides a very, very detailed audit log of which application, which token it uses token for everything. To authenticate, it uses token. So which token fetched what API key or what path and all these sort of things. What time was it? Which location? So you can have locations as well because it's data center compatible, multi-data center compatible. So you can have locations from where it was fetched. what was the purpose of it, what was the lease of it, and was it renewable or not, and these sort of things. Multiple client access backend is Vault is actually designed to be native to cloud. So it has access control built into it, and with multiple access backend as well. You can have EC2 instances. You don't need any IAM role, any credentials, except for the fact that in Vault you configure it once, and EC2 instance, every EC2 instance has something called metadata with the PKCS7 signed version of it. So you can actually send that and configure Vault to allow from a certain account of AWS with a certain signed version, and if you want to go ahead, you can actually have a randomly generated key value pair that you can actually set in the tag value as well of the EC2 instance. So you don't need to have authentication based on token. You can actually authenticate your EC2 instance directly from Vault. That's something very that helps a lot if you don't want to hard code in your application your GitHub token. That is one of the way you can authenticate with Vault. Or if you have your custom LDAP server, you can use that. You can use Google Cloud, you can use Azure. So it supports a lot of it. And ACL, this is something by default Vault is designed to deny everything. If you don't specify to allow certain API key or a certain user with an ACL, nothing is allowed. Everything is by default denied. Yep. The best part is you can generate secrets from inside your application. You don't need to actually go in and generate secret and then put in your application, because it provides the API that is that is actually secure, because everything in transit or at rest is secure, is encrypted. So your application can generate MySQL credentials directly rather than you providing it, or your application can generate S3 API rather than you providing it, or it can generate GitHub token, or a lot of stuff that is already supported in Vault. And if for example they don't have it, you can write your own backend which is pluggable, because everything in Vault is just a backend. There's no, like, the core itself literally is nothing. Everything is a plugin. So you can write your plugin for, let's say, if you want to use a certain third-party application that has API but does not have support for Vault, you can write your own plugin. Just simply just put it in one folder, and that's all you need. Most of the tools which are already out there require HSM, hardware security modules. Even Amazon does it. Amazon provides it. You can use it. It uses 256-bit AES encryption, which is really powerful. That's it. This is basically a small version of why we chose Vault to do this sort of thing. The reason is very simple, because we have a lot of API keys with 40 microservices and one monolith. Like, we have a lot of data that we want to encrypt. With Beanstalk, not just Beanstalk, in ECS and Beanstalk, in these sort of things, there are limitations of how many environment variables you can put into a size. So we have been trying out different services, different utilities, and then we started using Vault. So I'll give a small live demo just to give an idea how we can use Vault from inside the application. Yeah. Okay. So I have this Docker Compose file. It's just booting up one MySQL Docker and a Vault instance. I'm using Vault in a dev environment. So whenever you start Vault in dev environment, it is using in-memory store, and it is unsealed. Sealing and unsealing of vault is a very big topic, so I will not go in depth of that. So this is what okay. So by default, Vault supports only two methods, which is one generic, which is secret. You can put anything in there, and you can fetch from anything from there. And something called cubbyhole, which is you can use encryption as service. With cubbyhole, you can put anything and share it with anyone and use it. It is not permanent. It is temporary. So it is something like you need something for 1 minute or 2 minutes. You want to share some of your code or something with with your colleagues. You can use that. So to overcome that, we can mount the MySQL backend, and the similar way we can mount a AWS backend. We can mount a lot of different backends that is available. So it's just I'm dropping a database if it's there, creating a database. So here I'm mounting. This is where you can literally configure MySQL backend, and then whatever role you want read-only role to a certain user, to a certain certain database or something like that, and that's it. Yep. Then I have this very small Python application in Flask. I'm using a dev environment, so the token is over here, but in production environment, EC2 authentication is the best method to go. So you don't need to provide any token or anything. EC2 instance directly authenticates with it. Simple, it's fetching the token, and every time I access the root of it, it will generate a new MySQL credential for me, and just we can use that in any way we want. So every time you generate it, every time you refresh it, every time you actually access that path, these are literally MySQL username password, which should be used in the application, not something that that is hard coded in any environment variables, because this is not available to any process in the system in the Docker except for the application that actually accessed it. By default, the lease time for these is set to 31 days. You can set that to 1 day, 1 minute. That's up to you guys. That's up to how you configure Vault. But ideally, the best practice to perform application secrets handling in application is this: that every time you generate a MySQL credential has to be dynamic. Every time you generate an API key has to be dynamic, because then you know that only that certain application is using it for certain time and for certain purpose, nothing else. Yep, that's it.
So how we store root passwords?
Sorry?
Create the credentials in MySQL. How you store root password to create these credentials?
So this is how we configure. The MySQL backend. So the configuration part of Vault is always recommended to be manual, because you cannot, when you put it in production, you'll understand you cannot just run the Vault part. You have to unseal it, you have to initialize it. To initialize it, you need to make sure that you have at least n number of keys, private keys available. So n number of person are there to make sure that the Vault is unsealed. It uses something called Shamir's algorithm to unseal the Vault. So it requires, when you initialize it, you have to provide the key threshold and the key pairs, how many generate and how many are required. So usually you can generate 10 key pairs, but you require only 4 of them. So you distribute them. You can use PGP encryption keys provided by your colleagues and just input them directly in the initialization part of Vault, and it will just spit out the keys encrypted in the PGP format with the keys you provide. So the configuration part is always manual with Vault. You can set up Vault, you can automate it, but the configuration and unsealing part is manual, and it is recommended by the Vault guys, the HashiCorp guys as well, because this is something that once you enter it, everything stored in Vault is encrypted. The only part where it's not encrypted is when the data is shown to you. That's it.